All right, welcome to the 2.1, 2.2 lecture. So, first thing we're going to start with today is linear equations. I know we've covered these a few times, but it's because they're extremely important. They're used quite a bit in mathematics. So, a linear equation in one variable has the form ax plus b equals 0, right? So you would plug in some numbers for a and b, and there'd be an x still in there. This is typically your mx plus b formula. Linear equation in two variables has the form ax plus by equals c, right? Where we would fill in some numbers for a, b, and c. We'd have the x's and y's in there. All right, so this is just some general reminders on problem solving, algebraic problem solving. Multiple steps involved in these, so these are good to watch out for. Okay, so first one here, they want us to solve for x. Remember when it says solve for x, that just means get x all by itself on one side of the equal sign, okay? All right, so first thing we look at this problem and we see fractions, right? Everyone loves fractions, correct? No? Nobody likes fractions, right? So let's just get rid of these fractions, right? If you remember, the way to get rid of fractions, right, there's a method called clearing the denominators. There's a couple other terms for it, but that's probably the one you've heard the most. So what we're going to do is we're going to look at the denominators of all the fractions on both sides of the equal sign, okay? So we have 3 and a 4 in our denominator. So what we're going to find is what's called the lowest common denominator. So LCD is lowest common denominator, all right? Usually that means just multiply the two numbers together, but sometimes you got to check and see if you can find something smaller that both of these numbers go into, okay? All right, this case is nice and easy. 3 times 4 is 12. So our common denominator, our lowest common denominator in this case is 12. So I'm going to move that over there. So what we're going to do to clear these denominators, to get rid of these fractions, is we're going to multiply both sides by 12. All right, notice my proper use of parentheses here. All right, so we can make this nice and easy. Now, what you could do is you could work harder, not smarter, but we want to work smarter, not harder. You could distribute the 12 in there and then divide everything up, but that's a pain, right? Let's just divide 12 by 4. We're allowed to do that, right? Because technically 12, or any whole number, is a fraction if we do that, right? Put 1 underneath it. So 12 over 4 is 3. So there we go. So we have 3, and keep our parentheses going. Don't forget those parentheses. Now on this one, of course, we're going to distribute. So I'm going to write it out. You don't always have to write it out as much as I am, but you should show work, of course. So we're going to end up with 12 times x over 3 plus 1 times 12 is 12, right? Okay. Again, so 12 over 3 we can reduce. That becomes a 4. All right. So on this side we have 4x plus 12. Now on the left side we're going to distribute, right? When we have something outside the parentheses, it means multiply. But remember, you've got to distribute. You've got to share with everything that's inside the parentheses. All right? So 3 times 3x is 9x. 3 times negative 2 is negative 6. All right, and then we're just going to play the algebra game, right? We're going to bring everything with an x to one side of the equal sign, everything without an x to the other side. So let's see. We're going to subtract 4x from both sides, right? Because we want all the x's on the left side. And since we want this 6 out of the left side of the equation, we'll add 6 to both sides. Okay? So let's see. Negative 6 plus 6 is 0. 4x minus 4x, that's 0. So let's see. We have 9 minus 4x is 5x. And 12 plus 6 is 18. All right, and then to get x completely by itself, we're just going to simply divide by 5. 5 divided by 5 is 1. So x equals 18 over 5. And there you go. There's your final answer. All right. All right, here's another problem. Same thing, it's a typo. Of course, that should be solved for y. Y is the variable here. Okay. So we're looking at this kind of a mess a little bit. So we're going to clean this one up before we start finding the common denominator. So what I just circled, we could multiply, right? So remember, when you're multiplying fractions, you multiply straight across the top, straight across the bottom, right? So that's going to give y over 5 minus y over 4 equals 7 over 20. All right, so again, we're going to find the LCD, the lowest common denominator. In this case, what we want to look at is we have a 5, a 4, and a 20 in the denominators. So what we notice is we know 5 goes into 20 evenly, right? And actually, so does 4. Since that's the case, or whenever that's the case, then in this case, we're going to have 20 as our lowest common denominator. Okay? So what we're going to do is multiply both sides of the equation by that LCD. So times 20 times 20. All right. So here we go, piece by piece. Remember, we're going to distribute the 20 to both of these fractions. So I'm going to write it out. You could do your reducing as you work, but I'm going to just show you so you know what we're doing. So we're doing 20 times y over 5 minus 20 times y over 4 equals, well, right here, this is nice. We have 20 divided by 20, so only the 7 survives. Okay, more reducing here. So 20 over 5 is 4. 20 over 4 is 5. So there we go. We have 4y minus 5y equals 7. Now we combine our like terms. We have only variable terms here on the left. 4y minus 5y, be careful, that's negative y equals 7. Now we want the y completely by itself, so we can either multiply by negative 1 on both sides or divide by negative 1 on both sides. It doesn't matter, it'll still work. So just for fun, let's multiply by negative 1 on both sides. Notice how I use the parentheses here for that negative 1, because if I don't do that, then it looks like 7 minus 1, which is not what we're doing. We're multiplying by negative 1. All right, so let's see. Negative times a negative is a positive, and negative 1 times 7 is negative 7. Now, if you remember back, there's an easy way to check, actually both of these problems. There's a way to check and see if you got the right answer. You just take the answer you got and plug it in for all the, in part A, plug it in for all the x's, and simplify. You should get the same thing on both sides of the equal sign, and same thing for the one we just did. You should plug in for all the y's, and you'll get 7/20. Okay, so always check your work. It's always a good thing to do. All right, let's see. Moving on here. All right, here's just another type of algebraic problem. It says solve for x if y equals 2.704. So that's just fancy talk for plug it in. Okay, so we're going to replace y with 2.704. Okay, and then we're just going to use our algebra skills here. So we're going to add 2.14 to both sides. And let's see, I didn't make these calculations yet, so I'll use my calculator to do this. So we have 2.704 plus 2.14. So that's 4.844 equals 1.384x. Now we want the x completely by itself, so we divide everything by 1.384. So that reduces away. So we get x equals, so let me do this on my calculator, divided by 1.384, and the answer is 3.5. And again, you can check that by plugging in for x in the original problem. Okay? Fun stuff, right? All right, let's see, applied problems. So for applied problems, you must remember to include units of measure with your answer. In other words, word problems, right? Anytime you have a word problem, you've got to put units on your answer. Yes, you will lose a point if you don't put units on your answer, even if you do everything else right. It's just one of those things, got to be careful, pay attention to it. All right, here's another example. It's hard for some people to pay off credit card debt in a reasonable period of time because of high interest rates. The interest paid on a $10,000 debt over 3 years is approximated by this linear equation here, right? Linear because it has the form y equals mx plus b. Dollars when the interest rate is x%. So they want to know what is the interest rate. In other words, what is x if the interest, y, is 1,637.6 or 60 cents. All right, so again, that's just fancy talk for plug in 1637.6 for y and solve. That's it. All right, so let's do that. So this one should be pretty quick. Sorry, I should have probably left more room here, but let's see, 1637.60 equals 175.393 x minus 116.287. So we're going to follow our basic algebra skills here. So add 116.287 to both sides. All right, so let's see, that's going to be that's going to be 1753.887 equals 175.393x. Then we divide by both sides by 175.393 because we want x completely by itself. 175.393. So that reduces away. So all we have is x on that side. All right, if we punch that into our calculator, we get something. I think you get like 0.9999 something. That's about 0.10, right? So in other words, so here, I know, off to the side here, we're going to write our answer here, but the, so we'll say the interest rate is about 10%. Okay, and if you put 9.99%, that's also fine, right? We're just approximating here. Okay, moving on. For a period of time, a man is very successful speculating on an internet stock, with its value growing to $100,000. However, the stock dropped rapidly, and its value has been reduced by 40%. So reduced by 40% of that original $100,000. What percent increase will have to occur before the latest value returns to $100,000? Okay, so this is one of those problems we've got to create these equations based on what they tell us. All right, so let's see. So he has $100,000, and it gets reduced by 40%. Reduced means subtract, right? So reduced by 40%, what they're saying is 40% of this original 100,000. So we'll say reduced by 0.4, that's 40%, right, of the original $100,000. All right, so what that's going to be is 100,000 minus 40,000, which equals 60,000. All right, so that was just the first part here. That's just figuring out what his money, his $100,000 is now worth. All right, drop down to 60,000. Next question is, what percent increase will have to occur before the latest value returns to $100,000? All right. So we're going to say, so this is a new equation, right? So we're going to start with the $60,000 now, times something we don't know. That's going to get us back to the $100,000. Okay? So 60,000x equals $100,000. We want to know what's that multiple on the 60,000 to get back to 100,000. So nice and easy, we divide by 60,000 on both sides, and x will be 1.666. Don't worry, it's just a number. But so if we converted this number to a percentage, that would be 166.6%. That's not how much the original 60,000 needs to increase, right? Because this 1 represents that original 60,000 still in there. All right, so in other words, the increase is just the decimal part. So it needs to increase by 66.6% to return. Can't spell. I really can't spell. That's funny. There we go. To return to $100,000. Okay? So basically what we did was we subtracted 1, because that 1 again represents that original 60,000. Okay? There we go. All right, next thing here, zeros of a function. So these are important terms, very important. Right? So everything we're covering right here is very, very, very important. You're going to be hearing these terms for all math classes you take after this, and including this class, of course. But they're important to understand. All right. So for any number a for which f of a equals 0. In other words, what they're saying is if we have some function and we plug in some value a, some x value, so a is really an x value. If we plug that x value in and we get a 0, that's called a 0 of the function. In other words, it's the y-intercept, right? I'm sorry, the x-intercept. If a is real, then a is, like I said, an x-intercept of the graph of the function. All right? All right, so the following 3 concepts are numerically the same. So know all these. Know that all of these are the same thing. Different ways to say the same thing. So the x-intercepts of the graph of y equals f of x, the real zeros of the function f, and the real solutions to the equation f of x equals 0. All of those things mean the same thing. They all mean x-intercept. So if you hear find the zeros or find the x-intercept, it means the same thing. Okay? All right. So let's see. Let's look at this example here. So for the function f of x equals 14x minus 56, find f of 4. So again, knowing function terminology and notation is very important. When they say f of 4, what they mean is take a 4 and plug it in wherever you see an x in the original. So that's what we're going to do. 14 times 4 minus 56. So if you punch that into a calculator, cool thing is you get a nice 0 there. Okay? So we're saying basically is we just figured out this one here. The real solution to the equation f of x equals 0, we just found out, is that x equals 4 value. Okay? So, since we said these 3 things are the same up here, oops, there we go, we can just answer part B, knowing that it means the same thing we just did. The 0 of f of x equals 14x minus 56 is x equals 4, because we just found out right up here, if we plug a 4 in, our answer is 0. Okay. Next, part C, the x-intercept. Well, again, that's the same thing right up here. So, but when they ask for the x-intercept, you need to give a coordinate point. Okay, so the x-intercept. Remember, when you want the x-intercept, you make y equal to 0. Correct? And that's what we just did right here. We found out that y equals 0 when x equals 4. Okay, so in other words, our coordinate point is 4, 0. That's our x-intercept. All right, in part D, again, same things. The solution to this equation, we just found that out in part A, didn't we? Oops, there we go. We just found that out in part A. If we plug A4 in, then we get 0. And we could figure that out even if we didn't know that first part, part A up there. All right, we could actually calculate this. 14x minus 56 equals 0. So we'd add 56 to both sides. So we get 14x equals 56. Divide by 14 on both sides, and x would equal 4. Okay, so that stuff's important to know. All right, now this part here is for your calculator. If you're going to use a TI-83 or 84, you're welcome to read over that. I'm not going to test you on anything that you need to plug into the calculator. I know not everyone has these graphing calculators. They're very expensive. If you have one, that's great. Try it out. But if not, no worries. Okay. No, so example 4, they're saying you use the x-intercept method and the intersection method. That's if we did it with the calculator. You can try it if you want by reading what they did up there. But again, I'm not going to do that to you on a test or a quiz or the homework. If there's homework problems that ask you to use the calculator, you're welcome to use the algebraic methods. Okay? All right, so here's the example. The function y equals 0.55x minus 2.886 describes the mean time y served in prison. So y is time served in prison for a crime as a function of the mean sentence length, x. Okay, where x and y are measured in months. To find the sentence for a crime that would give an expected time served of 10 years, write an equation and solve it by using those methods. But again, we're going to do this algebraically. All right, so they're saying time served of 10 years. In other words, that's y. They want us to put a 10 in for y. So 10 equals 0.55x minus 2.886. So we do our normal algebra stuff, right? Add 2.886 to both sides. All right, so we get 12.886 equals 0.55x. Of course, we're going to divide by 0.55 on both sides. Remember, whatever you do to one side, you must do to both sides. So we get an x on the right side there. And if you divide that in your calculator, I think you get something like 12.93. But if you know anything about the legal system, they're not going to say you've been sentenced to 12.93 years. They usually give whole years or half years or something like that. So we'll say approximately 13 years. Okay, so there we go, approximately 13 years. All right. Next is direct variation. So two variables, x and y, are proportional to each other or vary directly, same thing, if their quotient is a constant. That is, y is directly proportional to x, or y varies directly with x if x and y are related like this. So this is the one they usually show, but this is the version we're going to use. Okay, in other words, y equals kx. Now what you got to know is k is called the constant of proportionality or constant of variation, same thing. K is usually that, or not usually, but it is that multiplier that relates x and y together. Okay, so let's use an example here. This is a typical proportionality problem, or direct variation problem. So let's see, the blood alcohol percent of a 130-pound man is directly proportional. So whenever you see directly proportional, we're going to use that equation, y equals kx. Directly proportional to the number of drinks consumed, and 3 drinks give a blood alcohol percent of 0.087. Find the constant of proportionality. So that's the first thing we need to do. Find the constant of proportionality, and then the blood alcohol percent resulting from 5 drinks. Okay, so again, since it's a directly proportional, we're going to say y equals kx. But let's use variables that make more sense for this problem, right? So we have the blood alcohol content, right? So we could say A for alcohol content or alcohol percent is proportional to the number of drinks. All right, A equals KD. Alcohol level is proportional to the number of drinks. So they told us, let's see, for 3 drinks, so K times 3 drinks would give a blood alcohol percent of 0.087. Okay, so we want to find K. So simply divide by 3 on both sides. So that constant of proportionality is 0.029. So that's the first part we did here. They said find the constant of proportionality. So now what we're going to do is we're going to figure out this part here. What's the blood alcohol percent if someone has 5 drinks? So we're going to use the same K value. So again, alcohol is constant times the number of drinks. So let's see, we're trying to find A. We don't know that. But we know that they had 5 drinks, and we know that K is 0.029 times those 5 drinks. So punch that into your calculator, and you'll see that's something like 0.145, which is way over the legal limit. Okay, there you go. Make sure you work on these types of problems. They're important as well. All right, so section 2.2. Now, section 2.2. I'm going to read through it with you right now, but this stuff is not going to be on the exam, okay? Because, not everyone's going to have these calculators. And I took the homework. There's no homework for section 2.2 as well. All right, so let's see, exact and approximate linear models. So here we go. If the first differences of data outputs are constant for uniform inputs, the rate of change is constant, and a linear function can be found that fits the data exactly. If the first differences are nearly constant, a linear function can be found that is an approximate fit for the data, so a good approximation, not necessarily exact. All right, so what they're showing you here on this chart is the difference between each of these numbers each time is 1950. All right, so a constant change between the numbers means a linear function. So the rate of change is constant. 1950, using this rate of change and a point, gives the equation of the line that contains all the points, representing the annual retirement payment by Y and the years of service by X, and using the point 21, 40,950. So that's from the chart right here, this point right here. So we plug and chug. This is the point slope method, right? Point slope. All right, we plug in, and we get that linear equation right there. Okay. Note that the values in the table represent points satisfying a discrete function. Discrete function means a function with finite number of inputs, with each input representing the number of years of service. Although only points with integer inputs represent the annual retirement payments, we can model the application with the continuous function y equals 1950x, whose graph is a line that passes through the 5 data points. Informally, a continuous function can be defined as a function whose graph can be drawn over its domain without lifting the pen from the paper. So you've probably heard that definition before. So we must give a discrete interpretation to the model. Only inputs of the function that make sense are non-negative integers representing the number of years of service, right? You can't serve negative years, and you're not going to have negative dollars, right? All right, so there's a line that approximates all that data. So what you would do is use your calculator on these, okay? So in your calculator, and the directions are actually right here. All right, so find the line of best fit. This is the process you would use. Follow these directions. So on your calculator, hit the stat button, which is right next to your arrow keys, then hit enter. You'll see some lists. You should see L1 and L2 at the top. You're going to put the first set of data in L1, second set of data in L2. Then you're going to hit that stat button again. Then on the screen, you'll arrow right to calc and select option number 4 where it says linreg AX plus B. All right, just verify that X list says L1 and Y list says L2, and hit calculate, and you should see the graph. All right. So here's just some general information on modeling data. So step 1, enter the data into lists of a graphing utility. Step 2, create a scatter plot of the data to see if a linear model is reasonable. If you take statistics, you'll see a lot of this stuff in more detail. The data should appear to follow a linear pattern with no distinct curvature. Right? Linear means straight. Let's see. Step 3, use the graphing utility to obtain the linear equation that is the best fit for the data. Graph the linear function unrounded and the data points on the same graph to see how well the function fits the data. And then report the function and/or numerical results in a way that makes sense in the context of the problem, with the appropriate units and with the variables identified. Unless otherwise indicated, report functions with coefficients rounded to 3 decimal places. All right. All right, so if, like I said, I'm not going to go through this one. You can try it out on your own. But what you would end up doing is put all these years in order into L1, and then put all these population values into L2, and then you follow the directions right up above here that I just circled or boxed. That's going to get you that linear equation. Okay? All right, and then to estimate a population, or to estimate or approximate any of these, you take the years that they give you here, 2000 and 2010, and you plug them in to the equation you found in Part A. Okay, that's it. But again, that stuff will not be on the test. 2.2, again, not on the test. Okay, thank you.